Welcome to my video. I will be trying to solve this question, which is question number 3. Question number 3, it involves laws of Newton's. Specifically, here we're going to apply Newton's second law of motion. But before we go through the question, let us try to read the scenario and see what does the scenario has for us. Now, question number 3 for 8 marks, it says to us, figure below shows a block of mass m1 on a frictionless horizontal surface. It is pulled by a light string that passes over a frictionless and massless pulley. The other end of the string is connected to a block of mass m2, which is provided to be 3 kilograms. Now, the first question, which is number A, it says to us, find the acceleration of the blocks and the tension in the string in terms of m1, m2, as well as g, for 6 marks. And therefore, number B, it says to us, calculate the magnitudes of the acceleration and the tension for m1, whereby m1 is provided to be 5 kilograms and m2 is provided to be 3 kilograms. Now, when it comes to questions like this, how are we going to tackle questions like this? Now, we are given the scenario, we are also given the diagram. Okay, we have two objects, which is m1 and m2, and the most important thing that you need to take into consideration, it is the surfaces of these objects. Is this object placed on a certain surface, or it is not placed on any surface? Now, when we have a look at m1, it is placed on a horizontal surface, and this horizontal surface, we are already told that this horizontal surface, it is frictionless, meaning there is no frictional force that will be acting on mass 1 object. So Kamanzoma, the only forces that will be acting on mass 1 object, it will be a tensional force brought by this rope, it will be normal force, and it will be weight. And do not forget that the normal force and the weight of mass 1, they are equal, meaning sum of the vertical forces on m1 is 0. And then when you talk about the sum of horizontal forces of m1, it will be denoted only by tensional force. Okay, and therefore now when you talk about m2, it is not placed on any surface, but it is on air. It is suspended on air. Now, M2 will be experiencing two types of forces, whereby we're going to ignore air friction, meaning M2 will be experiencing tensional force and will be experiencing weight in a downward motion. Now, the first question, it says to us, we need to find the acceleration of the blocks as well as the tensions, meaning for question number A, we are solving for two parameters. Okay, we are looking for tension and we are also looking for acceleration. That's what you are looking for. But remember, they say to us, find the acceleration of the block and the tension in the string in terms of m1, m2, as well as g, for 6 marks. Okay, so now this is what is basically happening, guys. Now let's start with block m1. Okay, let's start talking about block m1. Okay, let's start talking about block m1. Now, block m1, if we want to calculate acceleration or tension, which formula are we going to use? We are going to use Newton's second law of motion. Sum of net force, sum of the forces is equals to mass multiplied by acceleration. Now, in this case, what are the sum of the forces that are acting on block m1? I said block m1 will be experiencing only tensional force, normal force, and the weight. But for a fact that weight and normal force, due to tensional force, it is parallel to the surface, the magnitude of the weight and the normal force will be 0 when you add them together. That means our net force acting on m1 will be only tensional force. So in this case, you're gonna say it's positive t, we choose to the right to be positive. It's positive t is equals to, now what is the mass of block m1? We're just going to write m1, and therefore what is the acceleration? It is unknown. We can just write acceleration. Okay, so now in this case, we managed to get our tension in terms of m1 and a, but the question wanted us to get the tension in terms of m1, m2, and g, not in terms of a. So now I'll just call this equation number 1. Okay, I'll just call this equation number 1, and therefore I move to block what? I move to block m2. So now when I get to block m2, remember block m2, it is suspended on air. I am also going to use Newton's second law of motion to solve this question. Now when I move to block m2, let's have a look at it. I'm going to say sum of the forces acting on block M2 is equals to mass multiplied by acceleration. Now in this case, what are the sum of the forces acting on block M2? Now let's have a look at block M2. We have tension, we also have weight. But now for a fact that the tension of M1 is positive, that means the tension of M2 is supposed to be negative. Remember that the tensional force of the two blocks is the same, it's just that they act in different opposite directions. So in this case here, we're going to have negative tension, and therefore because we have negative tension which is moving upwards on block M2, that means weight will be moving downwards. That means in this case our weight will be positive weight, which is positive mg. These are the sum of the forces acting on block M2 is equals to mass multiplied by acceleration. And now let us do the substitutions, okay? So now we have a negative tension, which is what we are basically looking for. And then the mass of M2 is just M2. And therefore, what is G? They said we just write G because we're going to have to solve A and T in terms of M1, M2, and G. So we're not going to substitute 9,8 yet. Is equals to, what is the mass of block M2? It's M2 multiplied by acceleration. And therefore I'm going to make T subject of the formula. I'm going to transpose T to the other side of the equation. I have positive T, and this side I have positive M2 multiplied by G, subtract M2 multiplied by what? Multiplied by A, okay? And therefore now this will be my tension from block M2. Now I will be calling this equation number 2. Okay, this will be equation number 2. And then as I continue with my calculations, remember I'm looking for tension, I am also looking for acceleration. But the thing is, I need to find these two parameters in terms of M1, M2, and the G. So now when you have a look at equation number 2, yes, I got my tension, but the problem is I got my tension in terms of A. And they said express tension in terms of M2 and the G. I don't even see M1 here, okay? So I'm going to equate these two equations, okay? I'm going to equate equation 1 to equation number 2. Therefore, T is equals to T. Sorry about that. T is equals to T. That means M1A, which is this equation number 1, is equals to M2G minus M2A, okay? And therefore M1A and M2A, we treat them as like terms due to the fact that they both have A. Now I'm going to transpose M2A to the other side of the equation. That means here I'm going to have M1A plus M2A is equals to M2G. And therefore I'm going to take A as a common factor. Here I take my A as a common factor. I left with M1 plus M2. M2 close bracket is equals to M2G. And therefore I divide both sides by M1 plus M2. That means A, which is my acceleration, will be equals to M2G divide by M1 plus M2. And therefore now I managed to express my acceleration in terms of M1, M2, as well as G, because the question, it said to us, find the acceleration of the blocks in terms of M1, M2, and G. Now we left with tension because it says find the acceleration of the blocks and the tension in the string in terms of these parameters. Now let's try to calculate for tension. Now we're going to say tension is equals to, you can take a simple equation. We're just going to take equation number 1, which is denoted to be what? Which is denoted to be M1 multiplied by A. Now we know A in terms of those parameters. Now we can say M1 multiplied by A in this case is M2 multiplied by G divided by M1 plus M2. And therefore in this case our tension will be equals to how much? Our tension therefore will be equals to M1 multiplied by M2 multiplied by G divided by M1 plus M2. And therefore this will be our final answers for question number A. And then for question number B, it says to us calculate the magnitude of the acceleration and the tension if m1 is 5 kilograms and m2 is 3 kilograms. So now, in order for us to calculate the magnitude of the acceleration and the tension, remember we expressed acceleration, this is number B, we expressed acceleration in terms of A, which is m2g over m1 plus m2. We said that acceleration is m2g over m1 plus m2. Let me confirm. Yes. And therefore now we are going to substitute then. So what is the magnitude of m2? The mass 2, they said, is 3 kilograms. Yes, it's 3 kilograms, and then g is 9,8 gravitational acceleration, and then mass is 5 kilograms, and then m2 is 3 kilograms. Therefore, what is magnitude of acceleration? Let's just try to punch this on our calculator. Open bracket, 3 multiplied by 9,8. What have I done? 9,8 close bracket, divide by what?